Good morning, everybody who's joining. We're just going to give it a few more minutes and allow everybody a chance to join. Good morning, everyone. I see everybody's connecting. That's great. I'll just maybe give about 2 more minutes and allow a few more people to join. Okay, I see we're 13 participants today. I have a feeling a few more people will be joining, but let's go ahead and get started. So good morning, everybody, and welcome to this April edition of Trainee Talks. Trainee Talks, as most of you know, is the monthly webinar series that showcases the research topics of our CREATE SE4AI trainees in their area of expertise related to software engineering and AI. And my name is Lori Akiyama. I'm the program coordinator here at Concordia, and I'll be moderating the webinar today. Today, we are very proud to welcome 2 more talented trainees from our group, Amanda and Jaskirat, who will be sharing their current research with us. So I would like to introduce both of the trainees, and then I'll turn things over to them for their presentations. Amanda Kolopanis is pursuing a master's degree in software engineering at Concordia University under the co-supervision of Dr. Tanya Taimel and Dr. Tristan Glatar. Her research interests involve utilizing AI and software practices to help solve ethical challenges in society. Her current research focuses on identifying gender discrimination in the software development field by examining feminist theories while using AI to extract and analyze online narratives. Amanda's talk is entitled Decoding Bias, Exploring Sexism in Software Development Through Online Narratives and AI Analysis. And immediately following Amanda's presentation, we will hear from Jaskirat. Jaskirat Singh is a master's student in software engineering at Queen's University, guided by Professors Bram Adams and Ahmed Hassan. Jaskirat has a bachelor's degree from Indraprastha University in India and 2 years of experience working as a software engineer on different technologies, frameworks, and languages like Splunk, Python, JavaScript, SQL, and ML libraries. He is also an AI enthusiast who is passionate about open source and new technologies. Jaskirat will be presenting his talk, Empirical Evaluation of Edge AI Deployment Strategies involving black box and white box operators. Each speaker will speak for 20 minutes, and then we will open up the floor to audience questions for about 10 minutes. The webinar will be available to view on our CREATE website and also on our YouTube channel, and I'll let you all know when the recording is available. So with that brief introduction, I'd like to turn things over to Amanda to begin her presentation. Take it away, Amanda.
Thank you so much, Lori, for the great introduction. I really appreciate it. And thank you, everyone, for your time today. I will be just sharing my screen now. And I will just confirm in a second, sorry. Okay, and one more. Okay, is my screen available for everyone? Okay, perfect. Okay, so without further ado, I'll be jumping into everything else. So for some background, like introduction, it's pretty evident that there's been a persistent gender gap within the software development field for quite some time. To go a little bit into the statistics, the distribution of women software developers remains somewhat stagnant over the past 12 years. If we look in 2010, it was reported that women are estimated to account for approximately 25 to 30% of employment in the IT industry. Whereas when we jump to 12 years later in 2022, it is still reported that women represent around less than 24% of employees in the software development industry. So this causes a couple of issues. We will first look at the social aspects of it. There's been numerous research and as well articles of women reporting that they don't feel the culture is really targeted for them, as in they feel a lot of like sexism and kind of not welcoming inside their development teams. So this is just a couple of them where they highlight they feel like a bro culture, they're assigned menial tasks, or they're kind of just outcasted. And all this to say, happening at lower levels, especially seen in the industry, it propagates to more extensive issues such as company walkouts, the employment kind of grabbing together and creating these groups to target their own companies. And finally, the critical one where it comes to $1 million in payouts of different lawsuits. So all this to say, there could be instances where the software development field is exhibiting some inhospitable characteristics that in all discourage women from either entering or persisting within the domain. And then looking at it at a technological side, we can see that the lack of women in software development leads to the technology containing some implicit gender biases. And of course, this is seen a lot in artificial intelligence as we have all these different areas of data imbalance and whatnot. So just for some high-level examples, we saw that in 2016, Microsoft released their Taybot, like Twitter, that was released on Twitter and then kind of produced like sexist and racist tweets within 16 hours without any training or monitoring. So then we also look at a more recent one where Apple's credit card system displayed some gender biases towards women's applications versus the male counterparts. And when they dug a little bit deep into it, they saw that there was an imbalance within the data sets, which caused all the results. And a really more alarming example that was done by UNESCO was they evaluated the virtual assistants, like the popular ones that are inside our laptops, our mobile devices, and they found that they respond to verbal sexual harassment to different ways, depending if it's a male or a female saying these statements. So for a little bit more context, I would just present an overview of the statements that they were using, and as well as the 4 virtual assistants that were being evaluated. And when a male was describing these statements, some of the bots would respond in like a flirtatious, a comedic, or more of a dismissive kind of approach. But when a woman said the exact same statements, they found that the virtual assistants were being more like, not the, what's the word? Sorry, I'm not stumbling. They're pretty much resisting it. They're saying, no, this is not all right. So in all with this, we can see that the technology is being developed with some inherent gender biases that ends up coming back to the end users. So it's kind of like a vicious cycle. It plays into society and comes into our technology. So with this, we say, how can we help solve it and contribute to research? We found that there are several online platforms such as Reddit, where they promote community discussions and interactions based on several topics. Specifically, we found some subreddits that focus on women's involvement in the software development domain. And while pondering upon all these different subreddits, we found that this platform enables women to share their personal experiences, advice, and suggestions for trying to navigate through the field in a supportive environment. So we figured that this can aid in identifying some possible true causes of the gender gap that's currently in software development that might not have been explored just yet. So the objective of this study is we would like to begin by creating a taxonomy that identifies the commonly experienced areas of sexism from women software developers using these popular feminist and gender theories. With this, we perform a case study on the experiences of women software developers by using the relevant Reddit content and applying some AI insights to determine whether these categories are actually reflected in these online narratives. And finally, with all this information and all this analysis, we would like to develop a code of conduct that software developer teams can kind of read up and follow to help reduce sexism as a whole at the lower level and kind of promote a more collaborative work environment to help with the gender gap. So then with this, we come to some research questions. We have our main research question, which is, how can AI help identify sexist experience of women in software development? Leading with this, we have research question 1, which identifies what categories of sexism are women most likely to experience in the software development field. And to follow, to what extent can semantic similarity effectively extract the experiences of women in software development that align with the constructed taxonomy? So this is where the AI insights come into play. So we have some contributions with this study. We first begin by constructing the simplified taxonomy to help describe the types of sexism that are most likely to be experienced in the field using these popular theories. We also assess the limitations of AI in identifying sexism in online discourses by evaluating the results with Concordia's Equity, Diversity, and Inclusion Lab, the EDI lab, of course. From here, we develop a code of conduct that software development teams can adopt to help reduce sexism towards women within their immediate groups. And finally, with all this to say, we're providing the necessary language to help discuss this issue of sexism in software development. Because even me speaking about it, it's not very easy, but having this kind of concrete approach makes it a little bit better. Okay, so with some related works, we look at the experiences of sexism that are currently mentioned in software development. And here I only mention the more recent ones that have been present in research, but there are many different types. So for instance, lately women software developers express some concerns about being labeled as a diversity hire by their peers. So this is where you join in and you're kind of just there to fill in the gap. This can be in industry, it could also be in academics with team projects. So you're not really valued for your technical accomplishments. As well, a lot of women software professionals experience micro inequities while feeling less recognized in their teams. And these micro inequities come as examples of being interrupted while speaking in meetings, having a lack of eye contact when having technical discussions, or being assigned meaningless tasks such as administrative or note takings. And lastly, one of these sadder experiences is that a lot of women software developers mention that they experience sexual harassment or purposely being excluded. So all this is really interesting and super helpful. But what sets us apart is that our research tries to explore often overlooked online narratives to either help support or expand on prior research that might have been overlooked when using traditional surveys or interviews. Following this, we also looked at the related works of sexism classification that's currently available in software engineering. And of course, it's a somewhat big area, but to just dive a little bit into it in a quicker note, there are popular events such as the sexism identification in social networks, where community members are asked to go and submit different papers to solve this sexism classification approach. And they have different tasks and different categories. But all this to say, they're not really held together. So one talks about sexual violence, misogyny, and non-sexual violence, while another approach talks about threats to harm, casual use of gender slurs. And lastly, this other paper was talking about having the most categories of sexism. But when you look into it, they said they were just speaking with a social scientist, and this is how they came up with the categories. So all this to say, our research aims to use a taxonomy that's supported by established gender and feminist theories, instead of trying to apply some arbitrary categories, where perhaps maybe we can find some true causes leading to this gender gap. So as a methodology overview, this is our diagram. We first begin with performing a literature review of popular gender and feminist theories. With all the literature review, we construct a taxonomy that also has a list of corresponding keywords. With the list of keywords, we perform the data extraction on a certain amount of subreddits using this static keyword matching. And then once we have this big subset of data that's from Reddit, we apply semantic similarity, aiming to extract women's software experiences that really pertain to our taxonomy definitions. Following this, we look at how the model performs. We evaluate where does it actually place the examples to the categories by doing a model evaluation with the EDI lab experts. And finally, we create our code of conduct that software development teams can utilize. I would like to mention that the last two are still a work in progress. I will just be briefly mentioning them in the presentation, but yeah, I thought it would be great to just kind of mention this. Okay, so for the literature review, we begin by reading the book Down Girl, The Logic of Misogyny by Kate Mayton, which was released in 2018. What's really important is this is the first book-length treatment of misogyny by someone working in the tradition of analytic feminist philosophy. And another important factor is that the book begins by canvassing a common dictionary definition style understanding of the notion of misogyny. So therefore, every definition that Mayne provides in this literature attaches a list of keywords that will be used for the data extraction later on. And you may be thinking, well, this presentation is about sexism. Why are we taking this logic from a misogynist literature review? So the whole concept, she describes sexism versus misogyny in two ways. Sexism is more defined as an ideology. It's a belief of what should be enforced, while misogyny is more of the actions and the real enforcement of patriarchy. So all this to say, we aim to use the concept of sexism as it offers more of a broader sense of the experiences that we can capture in this domain. With all the literature review, our taxonomy is constructed using 4 categories. These are defined as feminine coded goods and services, gendered split perception, testimonial injustice, and social dominance penalty. I'll dive into the definitions in a little bit when explaining the semantic areas, but just to keep this in mind, we have 4 categories from the literature review. So from this, as we mentioned before, we have a list of keywords, and each one of these keywords come from the literature, as she mentions on top, when talking about feminine coded goods and services. It's the promotion of gender roles through like affection, adoration, indulgence, etc. So with this, we build upon the list by looking at relevant synonyms that match the context of the research. So we use thesaurus.com, Collins Dictionary, and Merriam-Webster Dictionary. The goal of using 3 different resources is that we're really trying to ensure there's no overlap with the list of keywords and that we're focusing on the appropriate context per category. So we have the keywords. Now we analyze our 11 subreddits that focus on women in software development. We use the Python Reddit API wrapper to extract the posts and comments that contain these keywords for each one. In more details, we aim to extract the 2,000 most recent hot, top, and new posts with these affiliated words from 2018 to 2023. And also, just to provide some context, these are the 11 subreddits that we utilized. And on the right side, we could see their popularity based on the number of members that joined and participated in the discussions. Okay, so now we have our data set. What do we do with it? With us, we applied some semantic similarity. We decided to fine-tune a sentence BERT model using the all MPNet base 2 version to identify first women software developer experiences. As this is more broad to understand, we were able to build a training data set that contained 200 data points. It's still relatively small, but it was, anyway, yeah. So we have like 120 that are labeled as true and then 80 as false. They don't describe the context of experiences in software development. So with this fine-tuned model, we calculate the cosine similarity of the extracted data set with a generalized definition of what women's software development experiences we're looking for. So on the bottom, I won't explain the whole thing, but as a paraphrase, we're giving a first-person narrative to say, I am like a female software engineer. I experience these challenges while working with my teams, and this includes like hostility and sexism, just very broad. With this, with all the data being analyzed and then classified based on its similarity score, we determine a suitable threshold to help perform further analysis only on a subset of the original data sets. And then with this, we calculate the cosine similarity of the smaller data sets with the refined definitions and try to find the highest scores. And once we find the highest scores of the data points per each category, we evaluate the model's performance by calculating the top 10, 50, and 100 precision score per category. The goal of this is it helps to measure the quality of the model by determining the most relevant data points, as in like precision, without having to consider all the other potential instances that are present inside the data set, leading to recall and then later the F1 score. Okay, so then these are the refined definitions that we supplied to the model when doing the cosine similarity comparisons. Without jumping too much into it, I'll just give a brief overview. So feminine coded goods and services is denoted as the expectation to naturally provide certain traits to men or even women. It's really the reinforcement of traditional gender roles. So for example, women are expected to be more caring, or they're really utilized for their organizational or note-taking abilities within their teams. To continue with gender split perception, it's when women are experiencing harsher judgment when performing the same actions as their male counterparts. So an example of this is when women feel that their pull requests are, well, no, sorry. Yeah, when their source code is being more heavily scrutinized by their teammates compared to others. So then continuing with testimonial injustice, this is when women feel systematic biases when inside their teams, mainly being regarded as less credible. So they ignore their inputs, they don't want to listen to their feedback, they're kind of just put in the corner to do extra meaningless tasks. And then finally, with social dominance penalty, this is when individuals are purposely applying social penalties for women who are trying to compete for these masculine coded positions. They're perceived as either like arrogant or aggressive, when in reality, their male counterparts might not have the same outlook from their peers. So with this, we can see they sometimes experience a sense of hostility when just trying to provide constructive criticism or feedback for design in software and whatnot. Okay, so I'm running short on time. So for the methodology, with all this, we perform a model evaluation where we distributed a Google form to Concordia's EDI lab, and for the experts to manually classify 20 examples that were extracted from the data set. And then from here, we'll have our discussion and evaluate the analysis using Delphi technique in order to compare the results and evaluate it to what the model is actually producing to see if it aligns with what we actually want. So for some results, this is the distribution of the primary keywords that were provided by the literature review, and as well as the associated synonyms per category. They're all pretty much around the same distribution, aside from gender split perception, which is on the lower end. And this gets reflected later on in the results, as we'll just present. So here we're displaying the distribution of assigned key points, well, data points per taxonomy when we perform the subreddit data extraction. So this distribution is done just by matching the keywords per data and then putting it inside the category. We can see that feminine coded goods and services is on the really high end. And this was because the data contained a fair amount of like positive feedback, like good job, awesome, terrific, which aligned with those list of keywords. So this is why it's a little unbalanced in that sense. So then when looking at the top K precision for the evaluation of women's software developer experiences, we compared our approach using static keyword extraction to what we fine-tuned with the semantic similarity. So it actually was very profitable to fine-tune the model, as it increased by 0.6 as the score. As however, it kind of trickles off. So we're still looking at some improvements in this sense, but this has been our highest scores so far. Okay, so then to continue with the whole distribution, we look at the cosine distance. We try to find the most relevant data points. So with this, we set a threshold of 0.4 and was able to further analyze 4,781 data points. With this, we took the semantic similarity, we just did the cosine similarity with the definitions and attained this current distribution. So we can see again, feminine coded goods and services is on the higher end, and gendered split perception is still fairly low. So we do have some ideas of how we will try to improve this later on, but this is just for current state. Okay, and then finally for the results, these are the top K precision scores for each of the taxonomy given the BERT model. So we can see that, yeah, feminine coded goods and services and gendered split had more of the higher one. And while further looking into the results, testimonial injustice and social dominance penalty were oftentimes getting confused with the model. So we have some other approaches that we're going to look into to improve this as well. Okay, so for discussion, as just an overview, the preliminary data set analysis did identify a variety of sexist experience that were explained by women software developers, and they do coincide with already established research and our taxonomy. So for example, we found that colleagues automatically assume a fair amount of female software developers fall into the quality assurance or graphic designer roles, rather than affiliating them with software architects or more lower level development. And as well, a fair amount of the results showed that they face additional pressure when they're trying to improve their technical competence when working in male dominant development teams. And I didn't really mention it here, I forgot, but these results are also from a women's point. So sexism is not just male versus female, it's even women and women that experience these issues. Okay, so then for future work, we identified that there could be more categories that relate to misogyny and sexism towards women in the workplace. This study really just focuses on 4 as a starting point for future research and hopefully to more align with these kind of constructed theories and whatnot. As well, our list of keywords where relevant to each category is not exhaustive. We did not consider all positive words, and so this can be further analyzed to get more data in the beginning phases. And finally, the study does not consider intersectionality or explicit members of the LGBTQIA plus group. So we specifically consider individuals who identify as women and use the pronouns of she, her, or I in the data extraction process. Okay, so with all this, I say thank you for your time, and yeah, all you're listening in, and I'm open to questions.
Thank you very much, Amanda. That was very, very interesting subject matter and a great presentation. Does anyone have any questions for Amanda? Please feel free to raise your hand. Bram, please go ahead.
Great presentation. Thanks for that. So and lots of data, lots of analysis. That's great. So so I got a question. So you study a lot of Reddit groups, and how long does the data go back actually? Is it 1 year data, 5 years, or?
Some, depending on the creation of the Reddit, well, the subreddit, it can go back to, I saw early as 2012. But this is where, as the industry and also as our development teams changed, I was targeting for a 5-year duration to really be more aligned with the current experiences.
Okay, because if you go back 10 years or more in some cases, it could be interesting to see over time how things evolve, and especially the whole COVID period, to see if there was if things changed because everything was online. Was that a good thing for sexism, or a bad thing? Did it change? That could perhaps be interesting to study as well.
Oh, it's great feedback. Thank you. I'll definitely keep note of that. We'd like to look into that maybe.
Ooh, very good.
Thank you, Bram. I saw a few more raised hands. Does anyone else have anything they would like to clarify, or any comments for Amanda? Rashna, please go ahead.
Hi, thank you. Very nice talk, very encouraging talk, actually. I was surprised that the coding, I mean, the first coder was a lady, but nowadays women coders are decreasing. I would I was just thinking that while taking this research into account, did you take into consideration that women actually like to do coding, or they are afraid of coding, and they are being discriminated in industries and all those stuff, and that's why they are feeling, I mean, they are sidelined into a different task or job rather than being a developer?
So while going through the data, I have seen a lot of examples of that, to be honest. Even from the earlier stages where they express as a child, like they wanted to go into technology and they were more targeted towards like nursing or more caregiving. So there were a lot of that, and as well there are a lot of examples where women did not experience sexism. They blatantly said, like, I've been in the industry for this many years, it hasn't been an issue for me. But then they relate to another experience from one of their colleagues where they said, like, this happened to them. And to be completely transparent, we did not include those narratives in our data as further analysis because we're targeting personal. But it was, very interesting to see that it's kind of like little areas of sexism, and then the other ones say like where it comes from and how they feel about it. I think she's frozen.
Okay, Rashna, you're okay with that response? If so, we'll move on to Hassan.
Hey, Amanda. Thanks for your presentation. It was a lot of analysis. Thanks for that. So something that I found missing in the slides is what are some kind of practical, actionable implications for, let's say, researchers who are working in this area, or for practitioners such as, let's say, managers, team leaders? Can you reflect a bit on that? How could this taxonomy be used by the people to make it more actionable?
Oh, yes. Thank you for your question. So with this, we'd like to make it more actionable so that we can better describe the different cases of sexism. Because even right now, as like I'm out in the field and I'm talking with my colleagues about it, it's really difficult to describe these types of experiences. They're more generally described as, oh, it's blatant sexism or subtle sexism, but this doesn't really give us the terms to discuss what's really the issue. So with this, we do want to begin with our code of conduct, where we start with a generalization of these experiences and how they can kind of be diminished a little bit. But it would be really neat to have it at like an industry level where we can say, let's say, for example, if women feel that their pull requests are taking longer to be reviewed, an approach would be have a duration that's accomplishable for everyone. If you're going to take so-and-so time to review somebody, you have to just mention, like, I'm busy with the schedule, I will allocate this time for you, kind of add a prioritization. So just little tips and tricks like this to really help broaden the aspects for like academics, lower, and also industry level.
Perfect. Thank you, Amanda.
Thank you.
All right. Oh, Tanya, please go ahead.
Hi, everyone. Hi, Amanda. I'm sorry, I was late. I was in another meeting, so very sorry, but I'm right back to the discussion. Thanks, Hassan, for your comment, and also thanks, Rachna. I think these are very important comments, and also Bram about the time. I think that's also important to take into consideration what factor plays time. Now, Hassan, back to you. I think this research can be a very valuable contribution to academics, not only to industry, but also to academics, to really understand what exactly means sexism. Built on this theory about sexism and building on the taxonomy that Amanda used, this can be a very valuable contribution, for example, to develop codes of conducts for teams, also for academic teams, but also for industry, of course, because many people are using this language and they are not aware that this is actually sexism. So this is a theoretical concept which is now put into practice via this research, and which can be a valuable contribution for a code of conduct. And back to Rashna's question, these women that you were describing, they dropped out. They are actually missing in the data. So we need to, and that's basically also the limitation of the data. The number could be much higher, the cases could be much higher, but the women who would have been in development teams but dropped out in an earlier stage are already missing. So I think that's a good aspect that we could take into consideration. So thank you all. Thanks.
Thank you.
Thank you, Tanya.
Okay, wonderful. Thank you very much, everybody, for your positive feedback and responses to Amanda's presentation. And thanks again, Amanda, and wish you best of luck on your continued research.
Thank you so much, everyone.
So with that, I think we should turn things over to our next speaker. Jaskirat, if you're ready, please go ahead and share your screen.
Can you hear me?
Yeah, we're cutting out just a little bit. But I think,
Okay, I will share my screen.
yeah, you're fine.
Hello everyone. My name is Jaskirat Singh. I'm a master's student at SAIL Lab, MCI's lab, under the supervision of Dr. Bram Adams and Dr. Ahmed Hassan. My thesis topic is empirical evaluation of edge AI deployment strategies involving black box and white box operators. So, as you all know, there's a huge popularity of AI in our people's life. For example, the introduction of various large language models in various companies like Microsoft, Google, and Apple has basically improved the assisted the people in their day-to-day life. For example, the Apple's new MM1 AI model, which was introduced in personal assistant Siri devices, has provided generative AI capabilities for users. And Google's assistant with Brad generative AI model has also provided feasibility for users to ask anything about anything about whatever they want to ask, or they need any assistance. The motivation now here is to improve the performance of these large language models in the devices. And so by performance, I mean the latency, how we can improve the latency in these AI models when they are deployed in devices, various kind of devices like cloud or mobile. So when we deploy AI models in various kind of devices like cloud, we have some issues with the data transmission. And when we deploy them in mobile devices, we have data privacy, but the computation is low. So therefore, now the goal is how we can improve the latency of these large language models or AI models, and in these various deployment constraints. So the limitation of traditional deployment devices like cloud deployment is that they provide privacy leakage, because the data has to be transferred across the wide area network, and their transmission latency is slower because the cloud is situated as a wide distance from the mobile. But they provide faster computation capabilities because cloud has a vast number of GPU servers. For mobile deployment, The problem is they are smaller in size and they are resource constrained. So the computational is slower, and the only advantage they have is they provide privacy, data privacy, and confidentiality to the user, because the models which are there, they are attached to the mobile, and the data doesn't have to be transferred to the any other devices. So introduction of Edge AI as a promising solution. So by Edge AI, what does it mean is when we introduce Edge environment in the intersection of mobile and cloud, which provides benefits as for example, the faster transmission latency than cloud, because Edge is situated in a closer proximity to the mobile device. So the inferences which have to be performed, it doesn't have to go all the way to the cloud. It can directly be transferred to Edge and return back to the mobile. Other thing is the faster computation than mobile. The Edge servers have a higher computational capacity than our personal devices. So due to these advantages, we considered Edge AI environment as described here. So in our Edge AI setup, we basically consider various deployment operators. By deployment operators, we mean various deployment techniques related to model optimization. The first technique is model partitioning, where we basically split the model into two equal halves, such that the first half gets the input data, and the intermediate results are transferred across the Edge AI setup to the second half partition model. And from the second half partition model, the output result is transferred back to the mobile device. So the black box, what does it mean by black box and white box? Black box means when the models are doesn't require any training. And when we say white box, it means that the models require training or fine tuning. So the other technique is the quantization. So for quantization, the activations and weights of the neural network are reduced to lower bits, like integer bits instead of floating point. So this can be done in two ways, in a white box or a black box way. In a white box means QAT, which is quantization aware training, which involves retraining of a model. And the other technique is SPTQ, which means static post-training quantization, which means the models are not trained. They are basically this technique is applied on the pre-trained models without requiring any fine tuning. The third technique is early exiting. It's a black box technique where we modify the neural network manually, such that we exit the models early before reaching the end of the neural network. So when we exit the models early, their output is used for prediction instead of going all the way to the end of the neural network. Next technique is model pruning, where we basically prune the models such that we cut the connections which are not very important in the neural network. And this helps in cases where we need better performance and at the cost of lower accuracy loss. The other technique is knowledge distillation, which requires training. It's a white box technique. So here basically a smaller version of a large model is being used instead of there are two terms like teacher model and student model. So the student model is trained from the outputs of the teacher model, which is already a pre-trained model, as well as the actual training data. Labels are also being used in parallel with the teacher model predictions to train the student model. So the objective of knowledge distillation is it provides faster latency, because the student model is smaller in size compared to the parent model, and the accuracy performance is the goal is to maintain that accuracy performance of the student model. So our thesis statement is black box and white box operators in an edge AI setup of mobile, edge, and cloud are able to achieve pragmatic accuracy and latency trade-offs to MLOps engineers during model deployment. And we introduce 2 chapters in our thesis. In the first chapter, we discuss about these black box operators with the 5 RQs, and in the next chapter, we discuss about the white box operators with 4 RQs. In our study, we considered image classification, segmentation, and text classification domain based inferences, where the input is either the text or image, and it goes to the ML model, and we get the prediction output. Now, the prediction output is either the labels, predicted labels, or the for the image classification and text classification task, or the segmented image for image segmentation task. So we have subject data sets which involve variety of range involving images and text. So the main motivation of considering diverse range of subject data sets was to evaluate their input data impact, the size input data size impact on the latency performance. And the subject models are based on computer vision and natural language processing models, as mentioned here. The evaluation metrics are based on their specific domains. For example, the top 1 and top 5% for the CV models, and F1 score for the NLP models. So the experimental setup of our thesis is described here. Here we have simulated containers for these 3 devices: mobile, edge, and cloud. So we considered a hardware simulation of these devices using Docker containers for reproducibility of these results, and as it can be used by any developer based on the network and the hardware configurations as described here. These hardware and network configurations were based on previous studies which considered similar kind of edge AI setup. For the inference, we consider sequential inference of data, which means the data goes from mobile to edge and from edge to cloud, and then comes back from cloud to edge and from edge to mobile in a sequential way, one after the other. The reason being, we wanted to analyze the impact of each of the data samples on the overall performance of the deployment operator, each of the deployment operators. And the various deployment operators we used are their optimized models are stored in ONNX format. It's interoperable format, which is more interpretable and feasible for performing these kind of operators. And the sample sizes of these models were varied, were variations of these sample sizes were used, specifically higher sample sizes to check their impact on the network bandwidth also. The first finding is we evaluate the impact of the original models, which are the models without any transformations. We call them as identity models, on the latency performance of mobile, edge, and cloud. We can see that for the first row, the top three models, ResNet, ResNext, and DUC, these models have higher input data size as in the data sets. So due to that, the transmission across the edge was showed faster latency, because the transmission across cloud, which has lower network bandwidth, increases the time for data transmission. In these kind of scenarios, edge was is a promising solution. For the bottom three models, FC and BERT and Robota, their input data samples were very small in size. Specifically for BERT and Robota, which are textual models, and these textual models have text as a data, which is smaller in size compared to image data. And for these, the cloud was a better solution, even though it has lower transmission latency. The reason being the data sample sizes were quite small, which didn't have much effect on the latency or in the transmission latency. So these models have, as these are the original models, so there is no performance, accuracy performance changes. So the thing is how we can improve the latency, how we can make it more optimal. So we use the operators I discussed earlier. So the first, we evaluate the accuracy performance of the various black box and white box operators we discussed. And from these figures, we can see that the SPTQ and QAT models, which are the quantization variants, they showed the lowest accuracy drop when we compared them to the identity model, which is the original model. And other models showed higher accuracy drops compared to the quantized variants. So so this finding suggests that when MLOps engineers require lowest accuracy drops, quantization variants are a suitable choice for them. And next we discuss the mobile, the partitioning operator. So we here show the partitioning across the mobile edge in the graph, which is denoted by ME, shows better latency performance than the mobile deployment. The reason being, we partition the model across mobile and edge, which distributes the model load, and it improves the performance latency than deploying the whole model in a low resource environment such as mobile. And other than that, mobile the partitioning operator involves transferring intermediate data across the edge AI setup, which instead of actual data, which enhances the privacy, and because the instead of transferring intermediate data, instead of transferring actual input data, we transfer intermediate data across the network. Other than that, the other advantage of partitioning is that there is no change in the accuracy, because the models are just partitioned, their architecture is not changed. So yeah, so when faster latency is required at no accuracy loss, partitioning is a suitable choice. From the other operators like SPTQ, early exit, QAT, and partitioning, we see that the static post-training quantization was giving better results, as shown in this figure, in the edge device. Uh, uh, the thing is that static post-training quantization requires calibration data for fine-tuning the activations weights, and for the other operators which are like early exiting, their model size doesn't reduce as much as the SPTQ. And for the QAT, the QAT operations were slightly expensive when we were running them in the device. The reason being their operations were no, there were some exportability issues with those operations in the ONX format. Other than that, the SPTQ was also giving better results than the partitioning operator. So the next operator was distillation. So we see that for the distilled variants here, like distilled and distilled SPTQ, where we have faster latency performance than the other operators. So the reason being, distilled versions have the smallest model size compared to the other operators, because student models have lower parameters and lower computational requirements. And due to that, these student models can be deployed in low constrained devices like mobile and edge. And these models are beneficial when the fastest latency requirements are required compared to other operators. So going to the summary, we discuss various operators which involve both training and non-training based operators, and for various across various subject models like CV and NLP models, and discuss their impact on image data size, as well as discuss each of the operators on tier specific levels like mobile, edge, and cloud. And we see that for the partitioning operator, when is better than mobile at no accuracy loss. The quantized, when the least accuracy drop is required, quantized variants are suitable choice. Distilled variants are suitable in when fastest latency requirements are required. Thank you. If you have any questions, you can ask.
Thank you, Jaskirat. Does anyone have any questions or comments for Jaskirat about his presentation? We'll go Mohammed first, and then Ahmed, you can follow. Mohammed, please go ahead with your question.
Oh, no, I was just like clapping, using like that clapping reaction and not
you're
raising my hand. Yeah, yeah.
Okay.
Yeah, but like good presentation. Thank you. Thank you.
Thank you.
Okay. Ahmed, did you have a question?
Yes. First of all, hi everyone, and thank you, Jaskirat, for the nice presentation and for the nice study. Actually, so I'm not sure if I missed it. So can you explain a little bit what is the difference between Edge AI and federated learning?
In Edge AI, we basically introduce Edge server in between the mobile and cloud. The main goal is to improve the latency requirements when we deploy models in real-time applications. I think in federated learning, the thing is they do create different models based on different training data, like smaller versions of models, and they connect with each other for example, models are trained on different data sets, and each of these models are interconnected with each other in personal mobile devices, and they share their information to improve the accuracy performance. But in our case, it's more like we focused on model optimization, where we focus on how we can transform the models, deep neural networks, to make them more optimized for latency and accuracy performance. So each of these operators have some pros and cons based on these two metrics. Yeah.
Okay, thank you.
Thank you. Anirban, please go ahead.
Yeah, thanks. Hi, Jaskirat. Great presentation. I just had one question. So maybe I'm not understanding, but like let's say Edge AI is basically a component that's like sits between the user and the cloud, right? So what if I move this content delivery networks like the cloud closer to the user, and then I use this model? So then how does it impact the latency?
Yeah, so the thing is, like in various different studies, they consider different network and hardware configurations for the different devices. So obviously, we didn't explore wide range of configurations of these devices. We explored a particular scenario where the cloud has a higher computational resources, as studied in previous studies. Usually they have a very high computational resources, but they are far away compared to the user. So in those situations, how we can improve the latency. So we specifically the edge servers or edge devices like Raspberry Pi, they are situated near to the user, and so there's no need of going all the way to the cloud for the transfer of data. But yeah, the changing the different variations like cloud. If the cloud is situated in the same city as you are living, obviously the latency performance will be faster in that case. But we specifically created a scenario where the we can explore the importance of edge in our instead of traditional mobile and cloud, which have some limitations.
Understood. Thank you.
Okay, we're nearing the end of our time, but we do have time for one more question from Junji. Please go ahead.
Okay. Thank you. Thank you, Jaskirat. Very interesting talk. I'm wondering if for these black box and white box operators, I'm wondering if it's possible to like combine them together, like to increase like accuracy and improve the accuracy.
Yeah. So the thing is, we did hybrid operators in our study. For example, in the previous slide, the variants like distill, SPTQ, they are combined together. So the distill is a white box operator, SPTQ is a black box operator. So these two variants are combined together, and they got the lowest model size and the faster latency than even the distilled model. So we did various combinations which were feasible in our study. Other than that, we also did combinations with partitioning. For example, we first did the quantize the model first, and then we partition the quantized model. Here we can see that in the mobile edge ME, here we have two variants of ME. ME means like partitioning across mobile edge. So we have two variants. The first one is the partitioning of the identity original model, or the partitioning of the SPTQ model, which is the quantized model. So if we compare these various operators, hybrid operators also in these graphs. Yeah.
Thank you.
Okay, thank you very much, Jaskirat, and Thank you to both of our speakers, Amanda and Jaskirat, for their presentations today. And thank you to everybody for joining. We are going to have one final May edition of Trainee Talks in about a month's time. So I'll be sending out the details of that one shortly. And just a quick reminder to everybody to please submit your activity tracker spreadsheets to me. Anytime you attend a trainee talk or any kind of webinar like this one, I need you to note it down and include it in your activity trackers. And please get those into me as soon as possible. Thank you very much, everybody. Have a great day.
Thank you.
Thank you.
Thank
Bye.
you, Lori.
Thank you. Bye.
Thank you.
Thank you.